Myself Sneha, Department of Physics, Kottureshwara College. In last video, we discussed about the Newton's ring. In that, we derived an expression for the diameter and radius of the dark ring and diameter and radius of the bright fringe. In this video, we will discuss about the fringe width of the rings. Here, fringe width of the ring is nothing but the distance between the two consecutive dark ring, or the distance between the two consecutive bright fringe is nothing but a fringe width, or we can say width of the rings. As we know that in Newton's rings we will get bright and dark, alternative bright and dark fringes. Here we will discuss about the width of the dark fringes. Let's observe this. This is nothing but this D1, D2, D3 are nothing but diameters of the dark fringes. From last class, we derived an expression for the diameter of the dark fringe, that is D is equal to 2 into square root of R into M into lambda. Here D is nothing but a diameter of the dark ring, where R is nothing but a radius of curvature of the plane of convex lens, and M is nothing but a order of the fringes, where lambda is nothing but a wavelength of the monochromatic light. Here, if M value increases, then diameter of the rings also goes on increases. Let us see how this M and D values varies. Here D1, D2, D3 represents diameter of the first ring, diameter of the second ring, and diameter of the third ring. If M is equal to 1, then we will get D1 is equal to 2 into square root of R into lambda. If M is equal to 2, then we will get D2 is equal to 2 into square root of 2 into lambda into R. If M is equal to 3, then we will get D3 is equal to 2 into square root of 3 into lambda into R. Here D1, D2, D3 represents diameter of the first fringe, diameter of the second fringe, diameter of the third fringe, and diameter of the fourth fringe. Here this is the D1 is nothing but a diameter of the first fringe. Here D2 is nothing but a diameter of the second fringe, that is nothing but a diameter of the second ring. D3 is nothing but a diameter of the third ring. D4 is nothing but a diameter of the fourth ring. Here, as M value increases, their diameter of the rings also goes on increases. Now let us find out the width of the rings. Here width of the ring is nothing but the distance between two consecutive dark fringes is nothing but the width of the ring. Let us take it as a width between the first and the second ring, that is width between the second dark fringe and first dark fringe. That it is written as the width between the first and the second ring is equal to D2 minus D1. Here the distance between the second ring and the first ring is nothing but a width of the ring. Here we got the value of D2 and D1 from equation 2 and 3. Let us substitute in this. Then we will get D2 minus D1 is equal to 2 into square root of 2 into lambda into R minus 2 into square root of lambda into R. Here 2 into square root of lambda into R is common. I will take it outside. Then we will get 2 into square root of lambda into R into square root of 2 minus square root of 1. On simplifying, we will get the width between the first and the second ring is equal to 2 into square root of lambda into R into 0.4. Take it as a equation number 5. Similarly, let us find out the width between the third and the second ring. That is, the width between the second and the third ring is equal to D3 minus D2, where we got the value of D3 and D2 from equation 3 and 4. That is, D2 minus D3 is equal to 2 into square root of 3 into lambda into r minus 2 into square root of 2 into lambda into r. Here 2 into square root of lambda into r is common. I will take it outside. Then we'll get 2 into square root of lambda into r into square root of 3 minus square root of 2. On simplifying, we'll get the width between the second and the third ring is equal to 2 into square root of lambda into r into 0.3. Let us observe equation 5 and 6. Here the value goes on decreases. This shows us as the order of the fringe increases, then the width of the fringe goes on decreases. As the order of the fringe increases, then the width of the fringe will goes on decreases. From Newton's rings, we can also determine the wavelength of the monochromatic light. Here we'll discuss about the wavelength of the monochromatic light. Here let us consider two rings, that is mth ring and nth ring. Here mth ring is greater than nth ring. Then let us consider for the dark ring. As we know that diameter of the dark ring is equal to d into 2 into square root of lambda into r into m. Here for the mth ring we can write diameter as a dm is equal to 2 into square root of lambda into r into m. On squaring on both sides we'll get dm square is equal to 4 into lambda into r into m. Take it as a equation number 1. Let us consider for the nth ring. Then diameter of the nth ring can be written as dn is equal to 2 into square root of r into lambda into n. Similarly, on squaring on both sides, we'll get dn square is equal to 4 into lambda into r into n. Take it as a equation number 2. Let us subtract equation 1 in equation 2. Let us subtract equation 1 in equation 2. Then we'll get dm square minus dn square is equal to 4 into lambda into r into m minus 4 into lambda into r into n. Then dm square minus dn square is equal to, here 4 lambda r is common. I'll take this one outside. Then we'll get dm square minus dn square is equal to 4 into lambda into r into m minus 1. On rearranging, we'll get lambda is equal to dm square minus dn square whole divided by 4 into r into m minus n. Here lambda represents the wavelength of the monochromatic light, where dm represents the diameter of the mth ring and dn represents the diameter of the nth ring and r represents the radius of curvature of the plano convex lens, and m and n represents the order of the fringes. Thank you.